All right, for this next part, we're going to be doing the next part of Project 2 for RTDSP, which is going to be a MATLAB implementation of sections 3.3.1 and sections 3.3.2. So over here, we're going to open up MATLAB real quick. So 3.3.1 deals with designing filters in MATLAB. So MATLAB comes with a function called filter, which will apply the coefficients of a filter of a IIR filter with feed-forward and feedback coefficients on a set of data. We're going to simulate an FIR filter, so we won't have any feedback coefficients. We'll only have feed-forward coefficients. So notice how my feedback coefficients are just 1 for no feedback. And this feed-forward is going to be a moving average filter. So a moving average filter is defined by the sum of all the coefficients adding up to 1. And each value is equally divided. So since I have 4 feed-forward coefficients, for a moving average filter, I have to divide 1 by 4, so I get each coefficient is 0.25 for each of these slots. Now I'm going to test it by using from an example in the book, using these data points right here. So to use these data points, I'm going to first pad some zeros at the end of this set of data. That way I can flush out the response all the way until there's all zeros left. So the MATLAB response, or the MATLAB command filter, will automatically apply the feed forward and feedback coefficients on X. And then I can just plot this using discrete time indices. And then I just plot it using a stem plot. So if I run this real quickly, open up, and I get some results, and these results will match what is in the book. So now the problem with performing the filtering this way is that this will not be a real-time process, as noted here, because using the filter command in MATLAB requires you to have all of the data points already at the moment. Instead of operating them in real time, it operates them in post after you've obtained all the data points. So this sort of filter is not going to be useful for real-time applications, because you can't use this command if you're just getting data as they come. This can only be performed when all data points have been obtained. So it can only be used in offline or post, but it can't be used in real time. So to alleviate that, we got section 3.3.2, which talks about developing a way to simulate in real time. So a good way to simulate it, or at least attempt to simulate in real time. So we are going to use the same data set as before. And we're going to still use a third order for a total of 4 samples. It's going to be a moving average filter, so we're still going to take 1 divided by the total number of coefficients, which is 4 for 0.25 for each of these coefficients. So now I'm going to create a buffer, and this buffer is going to store 4 values, with the first value in indice 1 in MATLAB, or indice 0 if you're in most other programming languages, will be the current value, and each value afterwards will be past input values. So to simulate a real-time operation, we're going to feed these input values one at a time by using a for loop. So this for loop will have an index value that goes from 1 to the total number of samples with extra zeros so this is the length of the data with the extra n, where this n is the order for extra zeros for padding to flush out the register so that everything becomes zeros at the end. So for each input, so let's start with the first index value. You start off with the output of 0, which is just initializing the output. And so then you will load the sample into the first slot of the buffer. But if the length is greater than the data value, then you'd load in zeros, because this is just to flush out the buffer with zeros at the end. So we're mainly looking at this line right here, which will take the input value at the index. So since it starts at 1, it'll take the first input value, store it in the first array, first element of the buffer. It'll then calculate the output by using the feed forward coefficients multiplied by the sample at each index, and it'll keep adding them together in a for loop to perform the dot product multiplication necessary. So then after that, it will plot each individual point on the graph. So then it'll plot it, and then it will first it'll create labels. I'll title this, and then it will make a stem plot of just the point. So this index -1 will just be a single value, and this y value is also just a single value, and I'll plot just a single point on there. Then right here, this shift is going to shift the buffer. So this is going to be a shift register. So it shifts each index down 1. And so then this is the end of the for loop. So that brings us back to the next sample. So then the next sample is calculated after everything's been shifted. The new sample will be dumped into the first slot again. You'll calculate everything. You'll plot that individual point again. So if I run this simulation, notice how each point is a different color because I'm plotting each of these as a separate series or as a separate plot, so to speak. So each of these points is calculated at that moment and is plotted. So this is a more closer representation of real time because the values are calculated as they come in, and then you notice that the results are still the same as when we did the original MATLAB process, but that one can only be done offline in post because that one required all the data points at once. But this simulation doesn't require the data points all at once, and you can feed them in. So this will be a closer representation of a real-time processing. And so this is the approach that will generally be taken when programming in C. We will be looking at values in real time and storing them in buffers, and then performing the outputs and then storing and then shifting them in shift buffers. So this MATLAB demonstration is mainly just to step up from just because we started with just WinDSK, just demonstrating what the effects are. And this MATLAB demonstration's main purpose is to start developing the logic and the design of how we're going to implement those effects. So in the next parts, we're going to start, let's see what the next parts are. The next parts, we're actually going to implement these in C, and we're going to use the design philosophy that we developed in MATLAB by using these buffers to create a filter in C and then download it onto our DSP board to actually operate on signals. So that's all for this part, and the next part we'll start coding in C.